Good morning. It's Halloween here today, but if this is the spring semester sometime in the future, it'll be some other day. But for me, it's Halloween. We are going to do the second day of circles now. I tend to combine topics that I think you might easily be able to learn combined, and it might help with differentiating between some things doing it this way. So we are going to talk about all of the angles and related arcs in circles today and how to use those. All right, so the first thing we need to do is define a couple of things. We need to talk about these little vocabulary words that we're going to be using. A chord in a circle is a segment whose endpoints are on the circle. Okay, a chord is a segment whose endpoints are on the circle. So a little diagram, I'll just draw one, I guess, over here. We have a circle, and there's a segment. It can be anywhere in the circle as long as both endpoints of the segment lie on the circle. The inside of the circle is really just empty space. A circle is a set of points equal distant from a certain point. So all of this is the circle. The inside is empty. Okay, so a chord touches it. A diameter is actually a chord. It's just a special chord that goes through the center. All right, so a chord is a segment whose endpoints are on the circle. A secant is a line that crosses through a circle. So it's like a chord, but it's extended like that. That's a secant. So it goes through the circle. And a tangent, this is different from the trig tangent, is a line or segment that touches a circle once. At one point. So it just kind of skims on the circle. So if you have a circle, a tangent looks like this. It goes boop, and it touches just at one point. That's a tangent. We're not going to be using these words, well, we'll use chord, but secant and tangent I'm going to describe in a different way. You just need to know what they are, especially tangent, because sometimes you'll see questions that are like, line L is tangent to circle P, and you need to know that that means it touches at just one point. All right, so this is how it works mathematically, algebraically, however you want to look at that. Central angles we've already talked about. You have the center of the circle, and a central angle has its vertex on the center. So something like that, like you're cutting a pie or something like that, a central angle. What makes it a central angle is the vertex is on the center. Sometimes angles will look like central angles, but unless you know it's the center, you cannot consider it a central angle. So this could be named circle A, and that's the center of the circle. We already learned that the central angle and its corresponding arc are congruent. So this angle here is the same as that arc. They are congruent. So a little formula would be angle equals arc. The measure of the angle and the measure of the arc are the same. And just for a review, a circle has 360 degrees. So if we wanted to figure out the measure of this bigger arc, this major arc over here, we would do 360 minus 68. And that ends up being 292 degrees just for this other one. Okay, which means that this angle here is 292 degrees. All right, and then we have three separate cases. We have when lines or segments cross in the circle, when they cross out of the circle, or when they cross on the circle. If they cross in the circle, you're going to have two secants or a secant and a chord or something like that that intersect inside the circle. I'm assuming that you can immediately see that we have some vertical angles in here and some linear pairs, and that's usable. But for now, we're just going to highlight specifically how you would figure out how these measures are related. So these two angles are obviously congruent. And the way that it works is angle, so I'm just going to choose one of them right now, is related to this arc here and this arc here. And it's actually just the average of that. So we're going to say for in, if they cross in, it's angle equals 1/2 arc plus arc. You need to memorize that. Angle equals 1/2 arc plus arc. So this orange angle is half of this arc plus this arc. All right. And then we have when they intersect outside of the circle. These lines could keep going, but it usually looks more like this. This actually creates two arcs. First, you have your angle, and you have this small arc here, and then you have a big arc out here. I hope you can see kind of what I mean, but what I'm talking about is kind of the parts that the angle would cut out. So if you think about scissors here, it's going to cut this piece and that piece out. Right? So small piece, big piece. That's what it looks like when they intersect out. And the little formula for that is angle equals 1/2 big minus small. And I mean big arc minus small arc. All right. And then we have two separate cases when they intersect on the circle. So we have this one, which has a special name. It's called an inscribed angle, meaning it's written in the circle. And then the other case looks like this. It's like a tangent and a chord, or a tangent and a secant. That doesn't really have a special name. Both of these have the same way to figure them out. The angle is related to the arc it cuts out. So again, with the scissors, you can see that's the arc cut out. This is the arc. I don't know if I can open the scissors like that. This is the arc that we're cutting out. Okay? So this angle is related to this arc. And the relationship is angle equals 1/2 of the arc. Okay? So these are all similar. Central angle is angle equals arc. Angle equals 1/2 arc plus arc. Angle equals 1/2 big minus small. And angle equals half of the arc. This needs to be memorized. This isn't something you're going to get a formula for. You just need to remember these relationships. So now I'm going to show you a couple examples. The first step is you need to decide, are we doing in, out, on, or central? Well, if we look at this one, these angles are all with their vertex on the center. So this is an example of a central angle problem. All right? And it says we want to find the measure of arc PST. So we're going to follow from P around to S and then to T, that whole arc. To figure this out, we're going to look at the angles inside. We actually have, I hope you can see this pair of vertical angles inside. So this one is actually 74 also, just because of vertical angles. And we know this one, so now we just have one missing piece. And you can figure this out a couple ways, but the way that I see it right off the bat is I see that these three angles form a straight line. They're on a diameter. Do you see that diameter going straight across the center? So we know that these three angles would have to add up to 180. So I'm going to do 74 plus 39, and then 180 minus 113. So this is 67 degrees. Now, I could have done this another way. I could have just written 180 for this and added that. There's a lot of ways, but I just wanted to show you that step. We know because of central angles that the angle equals the arc. So if this angle is 74, this arc is 74. If this is 67, the arc is 67. If the angle is 39, the arc is 39. And if the angle is 74, the arc is 74.